Well, to begin with, welcome everybody, and I must introduce which is my speech based on, and okay, I'm going to talk about immobilization and to understand which is the reason because we need to immobilize the photocatalyzers and particles which we work with. You need to understand which is my field of research, okay? So we use immobilization because we basically work on textiles, so it is a porous substrate, and we need to immobilize the particles that we are going to include on the textiles. We need to include particles to the textiles because it's something that is easy. All of us are wearing clothes. We have clothes at home, and we have home textiles like towels, like sheets. But nowadays, they can have an added value because we introduce new properties to them. And with these new properties, we are going to spread the field of application of textiles. So we need to introduce or to apply particles to textiles, and we need to be able to be sure that during the cycle life of the garment, we are going to have the same properties, okay? Sometimes it's not necessary to have all for example, a garment for 3 years and who lasts for 20 laundry cycles, the particles on the surface, okay? So sometimes it's something used as a medical disposal, so we use and we throw it away. And then we don't need to keep it for washing or for rubbing or for any other issue. But for textiles, imagine that one of the examples that I'm going to show you later on is going to be based on sun protection. Okay, if I use, for example, a t-shirt with sun protection, I wash it and I miss the sun protection, I have missed its effect, okay? So I need to immobilize that particles on the textiles. Okay, here you've got an example of some of the particles that we work with. We work with microparticles and with nanoparticles to be included on textiles because of a simple issue. We need to have little particles because if they are too big, when you add them to the fibers, you are going to change the touch of the garment, the mobility of the fibers, okay? So we introduce micro or nanoparticles. In this picture, you can see cotton fibers with microcapsules, okay? We use, for example, that microcapsules, and this is an example of a project in which we were involved. Okay, you can see here you've got the microcapsule. This is a whole microcapsule, and it is empty. And we applied on the textiles. We developed we applied the microcapsules on the sheets, and we went to 3 different regions in India so that we could test if these microcapsules were going to improve the anti-mosquito effect. So those people were sleeping on the sheets, and the day after, we could control the number of bites that that person had on its skin, okay? But if we wash the sheet and we miss the repellence effect, we are lost, okay? Another example would be microcapsules with aloe vera inside and chitosan on the shell. In that case, what we do is to give to the clothes a moisturizing effect for the skin, but also antimicrobial effect because of the chitosan presence. In that case, it was a project focused on atopic dermatitis for recent born babies, okay? So this is what we work with. We can work with microcapsules or with nanoparticles, okay? Micro and nanoparticles. This is for you to understand what we are working with, okay? Another example, okay, this are some products for the hair, for the pulse prevention, okay? This is another of the developments that we have. Okay? But now we are going to focus on what the immobilization techniques we use and how we can take advantage of this, okay? I think that at this stage, you can make an idea which is our purpose. We are focused on including new products to fibers so that those products in the shape of micro or nanoparticles are going to confer new properties to textiles, okay? And we need to fix those particles. How can we do it? Okay, basically, at textile level, what we do is to work in those 4 different ways, okay? We can include the particles on the polymer extrusion, okay? Of course, this is not possible for every kind of fiber, because if we work with synthetic fibers, we are going to extrude the polymer through a spinning process, and then in this way, we can include the polymer. In the polymer, we can include, now, okay, when we have the polymer melt and we spin it through the spinning process, we can obtain the fibers. If I include, for example, the microcapsule or the nanoparticles on the polymer, on the melting polymer, then it would be entrapped on the fiber. So I would have these products on the fiber. Which is the problem? If I'm going to include, for example, silver nanoparticles, obviously, when I've got them inside the fiber, the antibacterial effect would last as much as the fiber would be in its shape. So if I don't break the fiber, I will have the antibacterial effect. But if I include, for example, microcapsules with a fragrance, if I put the microcapsule inside the polymer, I'm not going to smell because I have it blocked, okay? So sometimes I can work with that kind of immobilization because I melt the polymer, I include the particle, and I've got it fixed inside the fiber. But sometimes I don't need it to be inside the polymer. I need to be on the surface. For example, a fragrance, when I wrap the fabric, I can smell the fragrance, okay? In that case, I can have it inside the polymer. But sometimes we have textiles which are made of synthetic fibers, like polyester, polyamide, acrylic, etc. But we also use fibers which are natural, like cotton, wool, silk. In those fibers, I can't use this technique because nature gives me the fiber and it is as nature gives it. So I need to try to apply those particles on the fiber surface, right? So the polymer extrusion is suitable for some of the applications and for part of the fibers, but not for every fiber, okay? Another technique that we can use, and we take advantage of the cross-section. So here, you've got on the slide a microfiber in which you can observe that it's made of different kind of cross-section in the fiber, okay? What we do is to include those particles between 2 fibers, okay? This is something that can be made because of the artificial or synthetic fibers, but also on the natural one. Here you've got, okay, you've got the image of a synthetic fiber and how you can entrap the particles inside the cross-section. But this image reflects a cotton fiber. And the cotton fiber, the shape that it has, it makes like a convex shape, and inside there, we can include those particles. One of the problems is that when we wash that fabric, sometimes this goes away. So we will need to take advantage of the cross-section, but also to be, depending on how much we want to last the effect, we will need to include a binder or an adhesive to be sure that it's going to last as much as we desire. Okay, another technique would be the electrospinning. By electrospinning, what we do is a nanofibers felt, and then with this, you can see in this slide, you can observe that we've got a fabric, a conventional fabric, and over this fabric, we included an electrospinning felt made of nanofibers. What do we get with this? As you can check, at the bottom of the slide, you can observe the conventional fiber and nanofibers. So obviously, what I can do is, if I add some nanoparticles on the fiber surface, those nanoparticles would be trapped because of the deposition of the electrospinning field. Okay? So this is going to help us to prevent the migration of those particles, right? Okay, this would be another example, and then we've got it in this surface. Obviously, this is not going to be useful for nowadays. It's not going to be useful for garments, okay? Because those nanofibers are too thick, and then we can break them easily. But, for example, for filtration or for any other kind of application in which we need to improve the properties and it's not going to be wrapped considerably, we can use this technique. For example, one of the developments was, that we did recently was for using it in acoustical field. Okay? So we included some particles, we protected them by electrospinning, and for example, if you want to use them on the roof, it improves the acoustical effect, and you don't need to touch too much. Okay, so this is a good solution. Right, and the most common one, and the one that we can see at any industry in this region, we have many textile industries, and this is the most common or the most expensive technique. Okay. We use some kind of binders, some kind of polymeric products to adhere the particles to the fiber surface. Okay, here in this slide you can observe, okay, the polymer in which we are joining some fibers, and here you can see the particles, the microcapsules in that case, with the binder so that it acts as an adhesive to bind the particle to the fiber. Right, in that case, we can see that nowadays there are many chemical compositions to be used as a binder. In textile, we can use acrylates, polyurethanes, dimethyl dihydroxyethylenurea, ethyl cellulose, polyethylene, polypropylene, alcohol polyvinyl, silicones, etc. Which is the most important concern that we have nowadays? That we need to consider biobinders, because the majority of them are synthetic. And when we use them, the wastewaters from textile industry are or have a very bad reputation. So what we are working on is in the development of new biobinders or new products. Okay, so here I'm going to explain you which is the problem that we can find or we can face when we use binders. When we use binders, one of the main problems would be that I can take or I can have fibers like you observe here, the fiber, and the microcapsule with the binder. But if I change the concentration of the binder, I've got a problem, because I can go to the what is called the igloo effect. In that case, my binder could cover the totality of the particle, and then I miss the effect. Okay? So at this step, what we need to do is research on trying to find which is the optimal concentration, not only because we are going to miss part of the properties, but also because we are wasting a lot of product on the wastewaters. Okay? So here you can observe the igloo effect, or in the one that we have on the right, you can observe that this is completely protected. So if we take the example that we said previously about the smell, in that case, we are not going to break them. Okay? So this is an important issue on textile companies. Right. And now an example with a photocatalyzer that we have been talking today, and I think that yesterday and tomorrow we will be talking about the titanium dioxide, okay? We use it for textiles, and, okay, we use it. I'm not going to explain you which is the reaction, because I'm sure that you know much more about it than we do, but I'm going to explain you an example of this and how, for example, the binder is going to influence the behavior. Okay, here we've got cotton fabric that was used with, treated with titanium dioxide by two techniques, okay? The one by spraying and another one by padding. And we could control the quantity of titanium dioxide we had on the cotton surface. Obviously, on the untreated sample with titanium, we had no titanium dioxide. Later on, what we did, it was to wash the fabric, and we washed the fabric once it had been treated with titanium dioxide, but also once it had been treated with titanium dioxide with an acrylic binder or with a polycarboxylic acid as a cross-linking agent, okay? We can observe that when we had no washes, we had a quantity of titanium dioxide, and after 1 or 5 washing cycles, we could still keep titanium dioxide on the surface. Right, so here we can observe that with no binder, the quantity of titanium dioxide is something that we could determine, but later on we observed that with the acrylic binder, the quantity of titanium dioxide was higher. And later on, with polycarboxylic acid, we had more than without binder, but not so much when we had the sample washed. Okay, this was a conclusion that the synthetic binder, the acrylic one, was working better, okay? But according to the presence of titanium dioxide on the surface. But, okay, what do we use titanium dioxide to functionalize the textile? Okay, we have characterized that we have cotton and titanium dioxide on the surface after 10 laundry cycles. But what do we want to improve on a cotton fabric when we add this? Okay, in that case, this morning it was said that it could be used, for example, for antibacterial effect. Okay, but I have not included this because we have not the possibility to test this in our laboratories. But we can use it to sun protection, to self-cleaning properties, or to reduce the pollutants concentration. For sun protection, here you've got an example. We've got a cotton fabric which was treated with titanium dioxide and with the polycarboxylic acid. And after the test, we could check that the ultraviolet protection factor, according to the international standard, was 1.54 for cotton fabric. This is the same as we can use or we can see on the creams that we use for sunbathing. Okay? We know that if you are going to the beach, you can use different UPF levels. From 15, 30, and 50 is the maximum, right? So the cotton fabric had 1.54. It means that you are going to be burned with those clothes. But when we add the titanium dioxide, the value is 300. The top is 50. So the international standard says that if you have this value, 300, you need to stamp 50. You cannot say more, okay? Some brands, you can say that they say 50 plus. Okay, this means 50 plus, okay? But 50 is the top. And when we use the polycarboxylic acid to bind or to immobilize the titanium dioxide on the surface, it is reduced, okay? But we still keep the 50. Okay, but we've got an influence because of the binder. Okay, so this is something that needs to be studied. Which is the binder that is going to behave better, and how can we improve the effect so that the binder is not going to influence so much. Okay, another application could be self-cleaning. This means I've got my cotton fabric, for example, you've got here, and you've got it dirty of wine. So titanium dioxide is going to help us to clean that kind of sheet or the towel or whatever, right? So how do we measure this? We do not control the catalytic effect of the titanium dioxide. What we do is we prepare the clothes, we put the wine on the cloth, we can calculate which is the change on the shade or on the quantity or the quantity of wine that we have there. And, okay, oh, well, sorry, I'm going to explain you. Sorry. Here. Okay, what we do is we measure in the color space, which is the color point for our fabric. When it is white, we are on the top of the sphere. When we've got wine, obviously, we will move on the axis regarding to the reddish color, okay? So with these coordinates, we can control which is the intensity of the stain on my fabric, right? And, okay, which is the effect? When I have my cloth, which is white, the L value, which moves from white to black, is 90.85. And here I've got some of the values. Sorry. Okay. Look, we've got cotton and cotton with 10 laundries. It means that the values, when we have dyed with wine, or we have the stain with wine, values are more or less the same. Okay? Before the sunlight, we've got 69. Okay? This means that when I've got the fabric dirty, we move from 90 to 69. When we have the fabric treated with titanium dioxide and polycarboxylic acid, we've got 69, with chitosan 71, and we control what happens if we have the fabric without the titanium dioxide. Okay? So let's go to summarize. We can observe that, for example, here we've got that when we have the fabric exposed 7 days to sunlight, the value of the whiteness moves from 69 to 86, or from 71 to 86. So we do not reach 90, but it means that the titanium dioxide acted on the wine, okay? And it moved towards whiteness. Does it happen when I have the cotton with the binders without titanium dioxide? We can check on this second part that no. After 7 days, I move from 72 to 76 or from 69 to 72. So in that case, the effect is due to the titanium dioxide, okay? And then we have a reaction between the wine stain and the titanium dioxide. And what happens when we have the fabric washed? Okay, well, sorry. Here, this is what we can see, okay? That we've got 86 or 76. So this means that it has not acted. And what happens when we go to 10 laundries? Okay, you can see this. Here, we've got that after 10 laundries, the values that I have after 7 days are basically the same. So this means that after 7 laundries, if you remember at the beginning, I said that after 10 laundries, we had missed more than 50% of the titanium dioxide. What does this mean? As we could see on the first speech this morning, we had a lot of concentration of titanium dioxide. So we have an excess of this product because after 10 laundries, I have missed more than 50% of the titanium dioxide, and I can still keep the whiteness effect is going to be more or less the same. So if we want it to be a catalyzer, it's going to be really important to have that the effect is going to be lasting during the laundry cycles, but we don't need to add it in excess, mainly because it's going to change the appearance and the touch of the fabrics, right? Another application would be the reduction of pollutants. Okay, this is something that came from a European project, PhotoCityTex. Okay, in this European photoreactor that perhaps some of you knows about it, we put some fabrics and we simulated the atmosphere. It was made in this atmosphere or in situ. We tested on a road on Valencia and in a school in Valencia. So we prepared some clothes and then we put them with some sensors to measure the NOx concentration. We could check that after a period, the concentration is reduced. As a consequence, we can observe, for example, on the PhotoCityTex webpage, an application that I did all the steps so that we could not need to check to connect to the webpage. You select the country, the season, and the street where you are going to control the NOx gauge. And then, in that case, you give the dimensions of the street and the facade of the building. I did the simulation, for example, for this square, and if we control that we have one of the buildings covered by a fabric with that quantity with the concentration of titanium dioxide, what we are going to get, depending on how we place the fabric on the facade, we are going to reduce 0.8 of NOx or 27.36 or 0.64. Okay? So this is another of the importance of that kind of products applied on textiles. But we need to immobilize it because if it rains, we cannot miss all the titanium dioxide. Okay? So this is all from my side, and I thank you very much for your attention.